I'm Ken Andrew with Non-Line of Sight Wireless, a consulting company for RF data link systems used for UAV, UGV applications. This is a three-part video series about what we can do to help you get your system to market and have the flight range and ground range that you and your customers expect. In the background is the Drone America demo room in Reno, Nevada, one of my long-term clients. Drone America is well connected to local, state, and national programs like NASA's UTM, a UAV traffic management initiative. To learn more about their programs and services, products and services, see www.droneamerica.com. So in this first video, I'll talk about who I am and a few of the major issues up through RF interference that kills the range of data links. See my second video for additional details about major issues. If you only want the overall concept and a few details, see video number 3. There I also talk about training your staff and your customer staff for increasing sales, especially when those customers are overseas. So who am I? An RF engineer with 50 years experience in digital and analog communications, including the latest software-defined radios, also known as data links using OFDM, mesh, and MIMO. So I got my first RF experience as a ham at age 12. That's where I started actually playing with transistors. And my commercial FCC radio license by the time I was 18. I have 5 years college, including advanced courses in digital signal processing, RF component and system design. So in my early 20s, I started out working as an FM radio tech for the state and the city of Riverside. On my mid-20s, I was a product engineer for Stoner Communications. There I designed solid-state FM repeaters and also solid-state single sideband. A few years later, in my late 20s, I was at C-Tech Audio working with these same kind of wireless systems for high-end FM wireless data links, or audio links. By age 30, I moved to a really interesting company called Tektronix. Tektronix is a major OEM of high-end programmable RF microwave gear. I was their field engineer, and I worked almost exclusively with aerospace, who designed high-performance military frequency hoppers and digital radar jammers, also known as DRFMs, digital RF memories. So what they needed for me was to design their RF test bench and also to train them on the front panel operations of those instruments. And I also wrote programming code to run those under program control. So after working for Tech for 16 years, I moved on to a marine radio company in Irvine, California, as their lead engineer for several years. I designed a marine trunking radio and mountain base station equipment to go with the marine radio. My last 9 years, from 2003 to 2012, I worked for GMS, Global Microwave Systems, also known as COBM, Tactical Comm, and Surveillance. There I was a field engineer providing microwave data links. Working for surveillance, of course, involved aircraft, UAVs, and UGVs. So I retired at age 66. I'm now 70 with a clear idea of what's needed to be an RF consultant in this industry. So over the years with COBM, most of my customers had a large staff of MEs and double Es, but very few people with RF data link experience. And hardly anyone had any test equipment. So my customers often spend from 6 months up to maybe 2 years developing their product. They usually fly in the nearby or on the ground in the local area. Then, with all their flight control problems and mechanical problems solved, they went for long-range testing that supports the system. Then things didn't work as expected. When they purchased an off-the-shelf data link, too often they only got 50 to 80% of the range. You can imagine, you want to get this thing to market, and all of a sudden you can't sell it because you're not getting the range that you're making this product for. So as one of those data link manufacturers, I got back those data links with some pretty nasty notes. This stuff doesn't work. What's wrong with it? Well, it did work. And 99.5% of the time, those modules met spec on the bench. There's nothing wrong with them. So we had enough profit in the sales of these modules that I'd go to the field, find out what the problems were with RF test equipment, and train my customers. These are some of the key things I found. First, some links weren't designed right. They didn't have the correct antenna patterns, and patterns were too narrow. When the aircraft would roll or pattern, signal wouldn't be received at the faraway stations. Antennas weren't located in the right place on the platform. There wasn't enough RF level built in the design to get the range they expected. And part of that's because the engineers looked up the path loss formula. They knew what the formulas were, but they didn't understand the issues, especially the complex new data modulations and how to read the spec sheets. Bench checking these units, I found the customers weren't reading the right specs. What they did is they assumed that the transmit output was the spec on the data sheet. Well, that spec often was a spec for low data rate, and when they wanted to configure this link for high speed data to support the HD video, then the link didn't work. It was 3 to 4 dB lower than what they expected. And also the receiver, because it was configured, was also another 3 to 4 dB lower. So the net effect is they're getting 2 to 4 times less range than what they designed for. So they of course didn't think the module was bad, sent it back to the manufacturer, and it wasn't. Today, when I design a link for an OEM, I bypass most of these problems. First, I bench check the modules and find out what the real specs are. I got to say, some of the work's a little bit shoddy right now. Some of these manufacturers don't meet their own spec if you know how to read them. And quite often, they're 2 or 3 dB low, both the transmit side and the receive side. So the net effect is getting about half the range that you would expect on paper. Another problem that comes up a lot is RF interference, commonly known as RFI. Once the data link is inserted into the platform, all of a sudden it's close to other digital things like the flight controller, high-def camera, and dozens of little switching power supplies that get into the data link, causing interference, usually through the antenna, but also through the wiring inside. So again, sending the module back to the manufacturer, it'll drive you crazy. There's nothing wrong with it. In some cases, the new data link also interferes and degrades other RF systems. So the new data link can cause your GPS to have far fewer signals than you expect, jam the Iridium SATCOM, and really gets into the ADS-B quite often. So RF modules are made to meet tough FCC emission specs, but if you got a 1 watt or 5 watt module and you're right up against a GPS receiver that wants to see sub-microvolt level, it's not going to work. So, but there is a workaround. So by adding a quality RF filter, you can fix some of these problems. This is kind of a short list of the RF problems, and it gets longer quicker. So anyway, once I was on site, I had the test equipment and the procedures to work through each issue. And of course, that sometimes took shielding, other cases filters, but once everything was solved, we were able to get the range that they expected. So I work with many of the RF data link modules available today. Often I have a pretty good idea what it takes to solve RF problems based on just experience, but of course, we really solve it is by having the right test equipment and procedures. So let me end this video for those who don't need more detail for an overview with few details and my on-site training program that will take your existing staff and get them up to speed. See video number 3. For 2 other major issues, see my video number 2. So until next time, Ken Andrew, Non-Line of Sight Wireless. Catch you later.